Hello everyone, welcome to Malik034 channel. This is Mallikarjun. In this today's session, I'm going to explain about RAC 11G release to architecture, where I'm going to cover each and every component of RAC 11G release to architecture and what are the background processes of RAC and what are the startup sequences in 11G release to architecture and what are the new features of this 11G release to architecture. This course is precisely helpful for the guys who are going to prepare for the interview, because this course is contain A to Z related to this RAC 11G release 2. And then also this course will be meant for guys who want to understand from the beginning in a short time. So this is of 35 to 45 minutes, so I'm going to try to cover entire thing. So the next course will be RAC 12C architecture with this new features. So let's get started with the today's course. The content for this today's course are going to be difference between the RAC and standalone database and Oracle Clusterware configuration, client connection to the database, and shared storage, RAC background processes, control file, data file, SP file, and voting disk OCR, OLR, and 11G Clusterware startup sequence, and how to find out RAC database and new features of 11gR2, and Clusterware troubleshooting logs. And the difference between the standalone and RAC database, obviously the standalone is one-to-one connection and RAC is many-to-one connection. If you see RAC database, it will be one-to-one, like one instance and one database, one-to-one connection. And in RAC database, there are n number of instances connected to one database. Combination of this n number of instances will give greater throughput for the application or end user connection. If you can make a note of that, RAC is configured with the multiple instances of Oracle running on many nodes, so that you get a greater throughput, and multiple instances of Oracle share a single physical database. So all instances are connected to single physical database, so that we can achieve many to one connection. The multiple inside resides on a different nodes and communicate with each other via cluster interconnect. So all the instances of different nodes will communicate using network hardware, that is via interconnects. The instance may enter and leave the cluster dynamically. So, and if you specify max instances in a cluster, so the number of instances will work within that maximum number of instances. If you mention 10 instances, so at any time maximum number of instances can live or run on that cluster is going to be 10. So instance share a common database that comprised of common data files, or n data, where all instance will access to that n data. Each instance is participating. The clustered configuration will have individual log files and rollback segment, undo segment. So if you have a 4 nodes, each 4 node has its own redo logs, it has its own undo, and it has its own rollback segments. So that is going to be individual to the instances, and remaining data file, control file are going to be same same for all the instances. All instances participating in the clustered configuration can simultaneously execute the transactions against the common shared database, right? So n number of instances can do independent jobs and execute the statements independently, even though the data is going to be shared across all the nodes. And what are the clusterware configuration component? If you see here, end application like a mobile or URL or tablet, whatever it is, a desktop client, whatever the end client connection, goes to a scan via scan, it will go to node VIP, and then through node VIP it will go to services of that individual node, and then it will connect to instance via local listener, and then there's a grid infrastructure software which manages clusterware software, and inside the grid infrastructure you can bifurcate as a ASM and clusterware, and then both will communicate using a heartbeat via interconnect, and then each node has its own particular OS, and then at the back end there will be shared storage where you can have your OCR files and data files. And then how the client connection happens. So these are my end application, like either desktop clients or application or any SQL plus stored or developer. So the connection will go to scan, Via scan listener, the connection will be handed over to the local listener, and through local listener the connection will be established to the particular instance. And then during the scan connection, two important things will happen. One is the high availability, and then the load balancing. High availability at the client side while connecting to the scan listener, like it is going to span 3 IPs, either of one IP client connection will going to connect. And then once it connected to scan listener via high availability, and then load balancing will come into picture. So the scan will hand it over to any one of the surviving node which has the least connection or which has the least load, that is leads to load balancing. So the scan will get to know which node has the least connection via pmon. Pmon is the one, like 4 nodes, all pmon in these 4 nodes going to collect what is the load on my server and what is the average connection on my server on this all 4 nodes. This pmon is collect load and connection details, and this pmon will collect the load and connection details. Similarly, this 2 node also, all the pmons running on this node will collect the information and pass it to the scan, and then scan will decide based upon that pmon response which node has the least connection, and then it will pass it to the that node. And then shared storage is nothing but you will be having your OCR and voting disk and your database actual data files. And then prior to 11g release to clusterware files cannot be on the ASM. Prior to 11g release to clusterware files cannot be on the on the ASM prior to 11g release to. So clusterware files are nothing but OCR voting file. OCR voting file we used to keep it outside ASM, but in 11gR2 onwards we are keeping OCR and voting disk in my clusterware disk groups. And access to the storage must be on the high speed network such as fiber channel or HBA. And example of those shared storage are EMC, HP, IBM, XIB, Hitachi, Fujitsu. And ASM is an intelligent volume manager, intelligent system file system volume manager, I can say. ASM is the replacement of my storage volume manager. Okay, so supported ASM disk groups, like what are supported files in my ASM disk group, like I can place my data files, control file, SP file, redo log, arcalog, flashback logs, data dump sets, and change tracking, rman change tracking, blockchain tracking, and rman image copies and backup set, OCR voting disk starting with the 11g release 2. All these files I can place it, and also in starting with the 12c I can place my password file as well. And then what are the RAC background process? First one is the GCS, global cache fusion. Global cache service. Global cache service will mainly help in cache fusion. What is cache fusion? Global cache service process, GCS. GCS is mainly helpful for this cache fusion. Cache fusion is nothing but the data block transfer between the cluster nodes. I have 4 cluster nodes. If the data block is already available in any of the instance, so that block can be transferred between across the cluster nodes. That is called cache fusion. RAC software provides up to 10 GCS processes, 0 to 9, and depending upon the amount of messaging traffic. However, there is by default 1 GCS process per pair of CPUs. In general, number of GCS process varies depending upon the amount of messaging traffic among the node in the cluster. So, but make sure default 1 GCS process per pair of CPUs. But again, this GCS process depends upon the amount of data transfer between the cluster nodes. So in the RAC software, 10 GCS processes are default, like 0 to 9. Oracle 10G added a new initialization parameter called GCS underscore server underscore process. This parameter allows you to set a number of GCS processes that are started to handle the interconnect traffic. Okay, if you set this parameter, so those many GCS processes will be started. The default is 2. Default is 2. Whenever if you don't set it, default 2 GCS process will be started. But it can be increased on the node based upon the requirement, and so based upon the traffic transfer between the nodes, and also based upon the number of CPUs. The transmit block image between the buffer cache in the different instances. This process is called cache fusion, and if there is a failure in the buffer transfer, it's called cache fusion failures in generic term, if I can say. If it is not able to transfer, or if it is a network disconnect, network heartbeat disconnect, you can say it as a cache fusion failure. But ideally there is no term like cache fusion failure, but there's a RAC term, cache fusion. Cache fusion is nothing but the block transfer between the cluster nodes. Okay, so other background processes are LMS, lock manager service, and global cache service process. What this LMS do? LMS process maintain a record of data file status and each cached block by recording into GRD, global resource directory. GRD table is the main table which will be holding all my cache details, which instance has which block. And if I have 4 instances, all the 4 instance detail, which instance has which block and which data it has, everything will be recorded in this global resource directory. If any connection comes to any of the instance, any request to the particular block, first it will read from the global resource directory, and then it will find out which instance has that particular block, and then it will read from that particular instance, and then it will be given it to the cluster. So which service help for this process? LMS, lock manager service, global cache service process. And what is the next process? LMD, lock manager daemon, global enqueue service daemon. What this LMD will do? This process manages incoming lock request. The LMD process manages incoming remote resource request within each instance. And then GES, global enqueue service. What this global enqueue service does? Global enqueue service daemon is a background agent process that manages the requests for resources to control the access to the block and global enqueues. It's kind of logs, right? I can say enqueue services are nothing but logs. In the RAC, it's a global enqueue service. It manages the lock manager service request for GCS resources and sends them to the service queue to handle by the GCS process. This GCS process also handles the global deadlock detection and remote resource request. Right, this GCS is nothing but, just for understanding, it is our normal logs in our traditional database. And then LMON is the lock monitor, global enqueue service monitor. This process is the GES master process, GES global enqueue service, and this LMON is the GES master process. The LMON process monitor the global enqueues and resource across the cluster and perform the global enqueues recovery operations. And LCK0, instance enqueue process. Instance enqueue process, what it will do? Instance enqueue process manages non-cache fusion resource requests such as library and raw cache and requests. It is individual to instance. This GCS is across the all the instances. It's a cluster resource, and this LCK is the individual to that particular instance. And control file, redo file, data file, and SP file, and other like password file and backup set, everything we can place it inside my disk group. But I'm just covering this. What are these files? RAC database contains CRD files, and which helps for database run successfully. CRD files are stored in a shared storage which are accessed through ASM. Okay, one is control files, which records, so everyone know, like which is a core file, which is a main file in our any of the database, which has a database structure and all the versions. And what the control file contain? Database name and name and location associated with data file and redo log files, and timestamps of database creation, and current log sequence number and checkpoint information. So everything, these information will be available in the control file. And redo log file records the current transaction information. Data file is actually physical data, and server parameter file is my p parameter file, which contains key pair values. It will be like init and instance name .vara on each node. and in the database level it will be plus data oversale. If your database is oversale, it's like sp file oversale dot ora. And Clusterware software component, voting disk and OCR. Voting disk is nothing but again it is a shared disk. All instance will be accessible to this voting disk, and this voting disk will be having my node membership information and the timestamp registration of each node. Right, so already covered detail about voting disk in my previous topic, but just to have voting disk, it has a two main area in this. One is the static data and one is the dynamic data. Static data has a node information, dynamic data has a node registration information. So basically for the usage of this voting disk is, first one is node membership, node registration, node membership information, and other one is during the split parent syndrome, no voting disk play an important role to evict the cluster nodes. And then to check that voting disk, CRCTL query vote CSS vote disk, it will say how many voting disk your cluster has. And Oracle recommends to have odd number of voting disk like 1, 3, 5, 7. And then OCR, what is OCR? Oracle Clusterware, Oracle Cluster Registry, Oracle Clusterware Registry. So this is the main registry information which contains everything about my cluster, all my cluster resource information, all my software, ASM, instance, listener, scan, VIP, all the information related to my entire cluster, everything will be present under my OCR. OCR is like a central repository, I can say. It has everything. Without, if any OCR corruption or anything, without OCR you cannot start your clusterware. So Clusterware uses OCR to store the information about all this RAC database, ESM, VIP, scan, all the service details, application details, everything it will be registered in this OCR. You can have 5 OCR location. Each OCR location must resides in a shared location. So you can have more than 5 OCR also. So yeah, but 5 is like recommended. To mirrored copy 2 is the default. You have to have with 2 different disk location or disk groups, so you can have based upon your design. And then how you can manage your OCR using Clusterware control utility or a service ETL utility or OCR config utility or DBCA. So any of this utility you can manage your OCR. And how to check your OCR, it will be etc oracle ocr.loc. If you check this one, it will say what is your OCR location, and then OCR will be automatically backed up inside grid DOM C data and hostname.ocr. Automatically backup every 4 hours, every day and weekly. So it has many backup strategy, like everything will be automated. And OLR is a local repository. OLR is local to that particular node. It will be having the resources mainly started from that particular node. It is local or individual to that particular node. If you have 4 nodes and all 4 node has its own local registry. So the purpose of OLR is, it is the very first file that accessed to the startup of your cluster. Whenever you do start up your cluster, where first it will look for OLR and then it will start ASM and then some of the main resources, and then once ASM started it will read OCR and then it will hand it over to the OCR and OCR will be read and then all the other resources will be started. But make sure this OLR is local to that particular node. It has some minimum information which are to be started once you start your clusterware. So where OLR located? OLR located on the individual nodes. So if you do cat etc oracle olr.loc, it will be having my OLR file and OLR grid home location. And what OLR contain? OLR contain versions of clusterware configuration and configuration of various resource which needs to be started when you start your clusterware. And starting with 11gR2, it has many steps of clusterware startup. I can say level 1, level 2, level 3, level 4. Level 1, these are the resource will start. Level 2, these are the resource will start. Level 3, these are the resource, and level 4, these are the resource. So each stage has its set of resource to be started. And main process is the OHSD process. And then there is a cat. If you do cat etc init tab, there is a respan will do, that is etc init OHSD. This will be ran and then that internally runs all other processes. So in a short summary of startup sequence, init spans init.ohsd, init tab will start init.ohsd process with the respan. It means whenever this is killed, it will be again restarted. Respan means restart again. which in turn start OHSD process, Oracle High Availability Service Daemon. This OHSD process daemon will span 4 processes. OHSD process will span 4 processes: CSSD agent, Ora root agent, Ora agent, and CSSD monitor at level 1. And at level 2, again setup processes CSDD, CRSD, and CTSSD, Disk ON, and ACFS. And coming to level 2, OHSD will span MDNSD, GIPCD, GPNPD, EVMD, and ASM. And at level 3, CRSD will span Ora agent and Ora root agent. And then at level 4, CRSD root agent spans this network service, CAN VIPs, Node VIPs, ACFS registry, and GNS VIPs. And at level 4, CRSD will span these many listeners, these many processes: ASM resource, Diskmon, DB, scan, so many processes. And then, okay, so the main important thing, right, whenever you do CRS CTL start CRS, immediately you will get the Clusterware resource started. So does it means all the Clusterware resource will be started? No, the answer is no, because the moment you do CRS CTL start resource, you will get a immediately prompt response back: CRS process is started. But what happens in the backend? The moment you do CRS CTL start CRS, there is a etc Oracle node name and root OHSD run. This file is updated with a restart. The moment you do CRS CTL start CRS, only this file will get updated with the content restart. And then that is the reason immediately you do CRS CTL start CRS, you will get a response immediately back: CRS started. And there is a particular service. What is that service? That service, that daemon is init.ohsd. That init.ohsd will read this file ohsd run, and every few seconds it will be that this init.ohsd process will be keep reading this file. The moment this init.ohsd file reads content of this file as a restart, then immediately it will keep starting all the Clusterware services in a backend. Right, so that is the reason the moment you do CRS CTL start CRS, immediately will say that you will get a response that cluster resource started, and then this OHSD run file will be updated with the restart. And then there is every second init.ohsd will be reading this file. The moment it see that the content of this file is a restart, backend it will start your Clusterware services. And then the moment how the next opposite of that is, the moment you do CRS CTL stop CRS, and again same file OHSD run becomes stop. The content of this OHSD content becomes stop, and then this init.ohsd process every second it will read this file, and it is a stop. It means it will stop there only. It will not start your Clusterware, and then it will stop there. It will stop there. Then consequently all the Clusterware services will go down immediately. And then the shutdown process will take a time, because you have to wait until all the resource will go down, and then the content of this OHSD run becomes stop, and then our init.ohsd process will read this one, and it will find out it is a stop sequence, and it will never ever try to start your Clusterware. And similarly, CRS CTL disable CRS and CRS CTL enable disable CRS, if you do, there is a particular file etc Oracle this cluster resource node name root CRS start file will be updated with the disable and enable. This is for enabling and disabling process, same as how you do CRS CTL start resource and CRS CTL stop resource, how this OHSD run become restart and stop. This enable and disable is updated in CRS start file, disable and enable. And then the next question is how to find your database is RAC or non-RAC, and the particular parameter is cluster underscore database. Log into that database and check for this cluster underscore database parameter. If it is a true, your database is a RAC database. If it is a false, your database is not a RAC database, it's a standalone database. And other method, you can check LMON process. LMON process of that particular database will tell whether your database is RAC or not. And also you can check SRVCTL config database. SRCTL config database name will tell your database is RAC database or not. There are so many processes, but these are just generic I kept here. And what are the new features of 11gR2? First one is scan. Scan I already explained. One of the main feature like single client access name, where handles the load balancing and high availability. It will internally span 3 IPs, and any client connection will get any one of the IP, and then via that IP it will connect to scan listener. Via scan listener it will go to node listener. Just to show you scan, I'll just go back to my previous slide. Okay, here it is. Okay, so scan, whenever client connection comes, it will go to scan. Scan will span any one of the IP. Default 3 IP will be assigned, 3 scan will be assigned, 3 scan listener will be assigned, and 3 scan VIP will be set up in your cluster. So one IP it will get, and through one IP it will connect to one of the scan, and via scan it will go to local listener. Local listener it will connect to particular instance. Okay, that is for scan. Scan is one of the new features. Scan can be established using the GNS or DNS. So the scan configuration you can use GNS, global naming service, or DNS. By using any one you can configure your scan. And other new features are Clusterware and ASM are shared same Oracle home. So that is called grid infrastructure home. We can call it as a grid infrastructure home. Is a only single Oracle home where Clusterware and ASM will together share that run from that grid Oracle home. And prior to that, we will be having Clusterware as a separate Oracle home and ASM as a separate Oracle home. So starting with 11G release 2, we have single grid Oracle home where your Clusterware and ASM will run. And time synchronization, there is a NTP and CTSSD. So either you can have a NTP or CTSSD. If your NTP is enabled in your server, your CTSSD cluster time synchronous service daemon become observer mode. And if you disable your NTP at the server level, your CTSSD become active mode. And rebootless restart. So I recently covered one topic in my YouTube channel regarding the node eviction or node fencing, and what are the different kind of why node is getting evicted from the cluster, and what are the root cause. Everything I covered. And also I covered this rebootless restart. Rebootless restart means prior to 11G release 2, the node eviction means it used to reboot the node, and starting with 11G release 2, rebootless, it is not going to reboot my Linux box or my server. It is just going to disable my or it is just going to stop my clusterware stack on that particular node, making clusterware stack as a hard restart, hard reboot, or hard restart flag. Hard restart flag will be set to my OHST process, and all the clusterware stack services IO process will be stopped in that particular node, and with the restart flag my stack will be stopped. So that is called rebootless. So node eviction is nothing but node eviction is not all the time server reboot. And starting with the 11G release 2, it is just a stopping of my clusterware stack. And again, fifth feature is HAIP, redundant interconnect, I can say. So with this HAIP concept, I am able to achieve my interconnect node communication like network heartbeat. That interconnect transition between the cluster node can be achieved with high availability and load balancing. And if one NIC card goes down, private NIC card goes down, other NIC card will be automatically enabled. You can have 4 interfaces in the private interconnect starting with 11G release 2. This is one of the redundant interconnect was one of the new feature they introduced in 11G release 2. And what are the troubleshooting logs? You can see the default and the grid home log and the node name. My grid home is going to be user on app 11204 grid and log, and the node name has all my troubleshooting log. Alert node name log, CRSD, CSSD, CTSSD, diskmon, event manager, GIPCD, JNSD, GPNPD, MDNSD, and OHSD. All this log will be find under this grid home log and node name. And what are these are the main logs for the daemon. You can check all the daemon services logs if any issue. And under CFG2 logs directory under Oracle base, You can find ASMCA, DBCA, and other configuration logs, and then ASM logs live under this Oracle based diag ASM and ASM instance name and trace. This is ASM alert log. ASM alert log, you can find it under diag directory. And there's a particular diag collect.pl script whenever cluster issue comes. So try to collect using diag collect.pl, which collects all the logs from that cluster where you have to just pass the timestamp during which time to which time. If particular time node went down, and then take a diag collect log during 30 minutes prior to that node goes down time, and then 30 minutes after the node goes down time, that 1 hour time period, you can just take the log, and then you can troubleshoot. So you can read those logs and find out what is the root cause for the node eviction. I hope with that I'm concluding today's session. So this is pretty useful for understanding entire architecture of 11g release 2. So my next topic is going to be Clusterware startup sequence and dependency. So I just briefed how the Clusterware startup sequence happens in a 4 phase. Each phase has setup, services will start. I just briefed you, but I'm going to cover in detail what is the sequence it is going to start, and what are the dependent, hard dependent, soft dependent services to start that service, and what I need. For example, CRSD to start, what it will look, CSSD to start, what it will look, and OHSD to start, what it will look, and GPNPD process to start, what it will look. So all these dependencies and what are the startup sequence, everything going to cover in detail. That is my next topic. And after that I'm planning to cover RAC 12c release 2 architecture, how I explained today's topic 11g release 2. Similarly, I'm going to explain 12c release 2 with all the background process, all 12c new features, and all the architecture difference compared with 11g and 12c. So everything I'm going to cover in next topic. So if you really like my videos, please like and share, and comment in my YouTube channel if you any concern. So I'll answer you back, guys. Thank you.